Right, hello everybody. Hope you're doing well in these weird times. It's snowing outside right now, which is just excellent. Alright, so I have tried to record this video several times. Let's hope that this run works. That's why it's come to you much later than I had originally anticipated. But without further ado, you all requested a couple of problems, and the problems that you requested, there was pretty much a theme where first off everyone wanted to see question 45, so I'm just going to do one question per video because, well, at least for 45 it gets really long. It is 4 tabs worth of pieces of paper, so bear with me. So question 45 basically is a titration question where we have a solution of acetic acid, and I want you to picture that the acetic acid is in a beaker, and then the sodium hydroxide is our titrant, and that is up in a burette, and we're adding specified volumes of that sodium hydroxide over time and measuring the pH as we add more and more sodium hydroxide. So we're looking at a pH curve, and we're mathematically determining how you would figure out the pH along each point in the pH curve. So let's just start off. We've got 35 milliliters of 0.150 molar acetic acid, and we are going to be slowly adding over time 0.150 molar sodium hydroxide. So for part A, we have 0 mils of sodium hydroxide, and so clearly we only have acetic acid. And so because we only are dealing with our weak acetic acid, we really just need to use our good old ice table paired with Ka to determine pH. So we have acetic acid dissociating into its conjugate base, the acetate ion, as well as H+, and we're going to ultimately need to figure out the H+ concentration in order to know the pH. And so the only thing we do know right now is that we have 0.150 molar acetic acid, and then we have 0 on the other side. So we do our changes minus x plus x plus x, just like we always would do, and then we'll use the appendices to figure out the Ka of acetic acid. In this case, it's 1.8 times 10 to the negative 5th. And so I just plug into a good old Ka expression, and I can assume that this x is going to go to 0 because it's basically negligible since we have such a small Ka. I solve for x. X is my H+ concentration, and then I take the negative log of this concentration, as you see down here, to get the pH of 2.78. So A was just like any other question that we are used to because we weren't dealing with the sodium hydroxide yet. For the rest of the problem, we have to worry about the sodium hydroxide and how much of it we have relevant to how much of the acetic acid that we have. And so I drew out for you here the neutralization reaction. So we have sodium hydroxide and acetic acid coming together to form a salt. In this case, it is sodium acetate and water. And you'll find with the neutralization reaction, there's always 2 things formed. It's always an ionic salt and water. So that's pretty standard. Okay, so we need to basically figure out how many moles of acetic acid we have and how many moles of sodium hydroxide we're adding to that acetic acid. And so to do that, I took the molarity of acetic acid and I multiplied it by, we have 35 liters to start with, 35 milliliters, so 0.0350 liters of the acetic acid to start with. Liters cancel, and I'm left with 0.00525 moles of the acetic acid. And I did the same thing for the sodium hydroxide, except we're starting with 17.5 milliliters of the sodium hydroxide. And so I used that to cancel out liters, get into moles of sodium hydroxide, and I have 0.00263 moles of that sodium hydroxide. In this case, because I have less sodium hydroxide than I do of the acetic acid, the sodium hydroxide is all going to get neutralized, and all I'm going to be left with is the acetic acid. And so that's why down here, I take the moles of acetic acid and I subtract from it the moles of the sodium hydroxide to basically figure out how many moles of that acetic acid I have left over. So I'll say that again, because this is a neutralization reaction and I have less sodium hydroxide than I do acetic acid, it's all getting used up. and I have leftover excess acetic acid. So the sodium hydroxide was basically the limiting reagent in this case. And so moving on to the next page, bear with me. I now have to figure out, so I know that I have from before, and sorry that this is a little funky looking, but this was the difference. This was how much acetic acid was left over. And to figure out the concentration of the acetic acid, I needed to change the total volume that it was out of, because we now have 35 milliliters of that acetic acid, but we also have 17.5 milliliters of the sodium hydroxide, and that changes the concentration of the acetic acid to 0.05 molar. Um, so what I want to take a second kind of to talk through is the fact that in this case, I have some acetic acid, but I also have some of the conjugate base that was being formed through the neutralization reaction. And because I'm at the half equivalence point, and this is the important part, the conjugate acid base pair, their concentrations are equal. And I know that I'm at the half equivalence point because I have half as many moles of sodium hydroxide as I do of acetic acid. And so at the half equivalence point, again, conjugate acid base pairs are equal, and that's something that you know from Henderson-Hasselbalch as well. And so I'm able to basically assume, because I have 0.05 molar acetic acid, I also have 0.05 molar acetate ion. And so I go ahead and I plug into my ice table expression down here. And again, I am now back to using the partial dissociation equation of acetic acid instead of the neutralization reaction with the sodium hydroxide, because all the sodium hydroxide has been used up. So it is this analyte right here who's determining our pH. So in the interest of time, I'm kind of going to gloss over it, but I knew that I had this much of each. I don't know how much hydrogen I have. I'm just assuming it's 0. I go ahead, build my Ka expression. I went ahead to save myself time and solved for H plus instead of Ka, because I already knew the Ka. And I just knew that the Ka was equal to H plus because these two are equal, the conjugate base acid base pair, and so these guys just cancel, and so H plus just equals Ka. And then the pH is just the negative log of the Ka, so 4.74. Okay, so now moving on, I have the same I have the same molarity of acetate. But now I'm in 69.5 milliliters of solution because I've now added to the acetate 34.5 milliliters of the sodium hydroxide. So I'm going to do basically the exact same process from part B and part C. I figure out I still have the same number of moles of acetate. It's just, or acetic acid, sorry, it's a 5.25 times 10 to the negative third from the problem above, but my amount of sodium hydroxide is going to change because now I have 34.5 milliliters instead of the 17.5, so I reconfigured my number of moles of sodium hydroxide. If we were in class, I'd say to you, all right, what do you think we do next? And I would hope that you would tell me that we're going to subtract the moles of sodium hydroxide from the moles of the acetic acid to figure out how many moles of acetic acid we have left over once all of that limiting sodium hydroxide has run out. And now I need to take the moles of the acetic acid and I need to divide it by the total volume of the solution. So that's that 35 milliliters we have from the acetic acid plus the 34.5 milliliters we have from the sodium hydroxide. And once again, we're left with only that acetic acid. And so we're going to look at that acetic acid dissociation equation again. All right, so moving on to page 3 of this really fun homework problem. So I'm just writing up here what I figured out on the last page, that my concentration of acetic acid is 1.1 times 10 to the negative 3 molar. 5.175 times 10 to the negative third moles of acetic acid went towards neutralizing the sodium hydroxide, and I know that because that's how much sodium hydroxide I had. And so at this point, as that acetic acid is being neutralized, however much acetic acid is being neutralized, the conjugate base is being formed. So because 5.175 times 10 to the negative third moles of acetic acid were neutralized, I formed that much of the conjugate acetate ion base. And then I divided that by the total volume of the solution to get the molarity of my conjugate base as well. And so now I'm going back down to my ice table, plugging in what I know. I know how much acetic acid I have. I know how much of that acetate ion I have. I know that I don't have any of this guy yet, and he's going to determine my pH, so he's who I'm going to be interested in solving for in the first place. I do what I always do with these kind of problems, plug into my Ka expression, assume x here and here to be negligible because the Ka is so small, solve for x, take the negative log of x, and I get my pH, 6.58. So we're still in slightly acidic solution. It's getting really close to being neutralized at 7 now. Part D is where that neutralization is actually really occurring. And that's because we are at the equivalence point. And I know that I'm at the equivalence point because the moles of titrant, so in this case sodium hydroxide, are equal to the moles of analyte, so the acetic acid. And I did the math out down here to prove to you all that they were equal. Equal concentrations, equal volumes, equal number of moles. And it doesn't matter that this guy's strong and this guy's weak, because we have equal volumes of equal concentrations, we have the same number of moles. And that's why I know that I'm at the equivalence point. So this means that all of our weak acid has been used up and only the conjugate base is actually going to remain. So if I were to take this minus this, I'd get 0, but however much of the weak acid I used up, I have that much conjugate base. And so going down here, this is how many moles of that conjugate base I would have used up. And this is that total volume. So this plus this divided to tell me that the concentration of my acetate ion is 0.075 molar. Moving down. So we're now working with a conjugate base, and remember, anytime that you're working with a weak base, we have to show its hydrolysis in water. And so I show you the acetate ion's hydrolysis in water to produce, once again, the acetic acid and that OH minus ion. So take a second to recognize the fact that I'm no longer working with H+, I'm now working with hydroxide instead. So I'd ask you here, what am I solving for? Am I solving for pH or pOH? And at this point, hopefully you could tell me that we're solving for the pOH and not the pH. Calm down, Casey. Okay, so now we plug in the molarity. We only have the acetate ion, and so we don't have any of this right now. And so we do our regular old expression, minus x for my reactants, plus x for my products. We find our equilibrium expressions, and moving on to page 4, we're going to plug into a KB expression, but the appendix, I always say that weirdly, doesn't give us appendix. Thank you. Doesn't, all right. Doesn't give us K. Doesn't give us KB, it gives us Ka. And so remember, Ka times Kb equals Kw, and Kw is 1.0 times 10 to the negative 14th. So I plug in chug for Kb, and I find that Kb is 5.6 times 10 to the negative 10th. So I plug all of that into that K-Brie expression and I solve for x. And that's how much OH minus I have. So I take the negative log of that and that gives me POH. And so then remember, pH plus POH equals 14. So 14 minus 5.19 gives me a pH of 8.81. Okay. So after the equivalence point, all of my original analyte, so in this case, the acetic acid, should be used up, and all I should have left is the titrant. And here we have a strong base titrant. So we need to figure out basically how much of that excess strong base we have, and that excess strong base is what's going to determine the pH and the pOH. So in this case, we have 35.5 milliliters of sodium hydroxide. So we do out the math to figure out how many moles of sodium hydroxide that is. It's 5.33 times 10 to the negative third moles of sodium hydroxide. So we take this number of moles of sodium hydroxide and we figure out how much of that is used up in the neutralization of the acetic acid. And we find out that we have 8.0 times 10 to the negative fifth moles of the sodium hydroxide left, so not a ton. And we divide that by the total liters of solution, so the 35 milliliters of acetic acid and the 35.5 milliliters of the sodium hydroxide to get a concentration of 1.1 times 10 to the negative third molar sodium hydroxide. And we can be excited at this point because it's a strong base, which means we don't need to use an ice table. We can just know that if we have this concentration of sodium hydroxide, we have the same concentration of just the hydroxide ion. So you take the negative log of this concentration, and you get the pOH because we're dealing with OH minus now. So 14 minus this gives me a pH of 11.303, which is very basic. And now, last part is part F. We have 50 milliliters of sodium hydroxide, so we have even more sodium hydroxide in excess. So hopefully at this point, you can tell me what you would do here. Figure out how many moles of sodium hydroxide this is, subtract from that number of moles of sodium hydroxide the moles of the acetic acid ion. I'm sorry, just acetic acid, not an ion. To figure out how much of this guy we've got left after the neutralization occurs, and then divide by the total volume of the solution. Again, we don't need to do an ice table because we're still dealing with a strong base. So we just take the negative log, get a pOH of 1.577, subtract this guy from 14, and find out that we have a very basic pH of 12.42. Question 46 is basically just like question 45. So try and use this video and my worked out solutions. These pages are also just on Google Classroom. So use my worked out solutions to try and do 46 if you're still struggling, and send me an email if there's anything else I can do to help you. I'm going to keep making videos tomorrow of the other questions you asked, but figured I'd get this one out of the way now since I figured this was probably the one that you were most waiting for. Have a nice night, and hope everyone's staying safe and having a nice couple weeks off, and I'll see you when I see you. And just let me know. Basically, some feedback would be, if you have any feedback for this or any better way you would do this, just let me know, and have a nice night.